That's the Intercity Express from York to Liverpool. Just one of more than 15,000 passenger trains that travel every day on Britain's railways. But these particular tracks have a special significance. It was here, exactly 150 years ago, that an event took place that was to revolutionize railway development.
3 steam locomotives were wheeled out in front of a vast crowd, while a sceptical railway company sat back and challenged engineers of the day to produce an engine that would pass a trial of speed and power. The winner was Rocket. This is the story of how Rocket and its competitors came to be built, and how, 150 years later, working replicas were constructed to run again at Rainhill.
So let's start at the beginning. Over here's Liverpool, behind me is Manchester. And in the 1820s, they were joined by a network of canals and river navigations that was already 50 years old. And a lot had happened in those 50 years. Cotton had happened. The Industrial Revolution had swept over Lancashire in a great wave of mill building, and the old system simply couldn't cope. So businessmen and industrialists got together, and they came up with a radical new solution, to join the 2 cities by a railway. And they turned to a man from the northeast, George Stephenson, who'd already proved his engineering ability by his work on the world's first public railway, the Stockton and Darlington. But here, Stephenson had formidable difficulties to overcome.
Over at Liverpool, the railway had to be driven through the hard rock in a deep cutting at Olive Mount. It had to be pushed across a great boggy morass of chat moss, and it had to be carried over the old rivals, the canals and rivers. All those difficulties were overcome, but there was still one question that needed to be answered. How were the wagons, the trucks and the coaches to be pulled on the new line? Well, George Stephenson thought he knew the answer all right because he was an engine builder. The answer was steam locomotives. Others weren't quite so sure. Cautious committee men worried over the problem and at last decided to send a deputation of experts over to the northeast to see the alternatives for themselves. 2 experienced engineers, John Raystrick and James Walker, cast their expert eyes over systems like this, trains of coal wagons being hauled along on cables worked by a stationary steam engine. It was a well-tried system, but there were obvious disadvantages in running a mainline railway in which trains were moved in a series of stops and starts from one winding engine to the next. This was the alternative, a colliery locomotive hauling coal away from the pit head to the boats waiting to ship it round the coast. The system worked, but it was by no means perfect. The engines were desperately slow, they were unreliable, and they had a nasty habit of breaking up the track. Locomotion, and this is a modern replica, was one of the most famous engines of the day. Designed by George Stephenson, it certainly worked on the most famous railway of the day. The Stockton and Darlington opened just 3 years before in 1825. But for all that, it was still little more than a glorified colliery line. Locomotion and the other engines did very well hauling coal, but the passengers still had to make do with horse-drawn coaches. So there was nothing here to make a really deep impression on the men from the Liverpool and Manchester.
Raystrick and Walker's report produced immediate action from Stephenson and his supporters. They produced a counterblast in favour of locomotives, and they seized on a suggestion in the original report. Why not, it said, hold a trial at Rainhill, where there's an incline worked by a stationary engine and a level section for locomotives. And in the words of the original report, something in the way of a premium might be held out to the person whose engine should, upon experience, be found to answer the best. On 20th of April, 1829, the Liverpool and Manchester Railway issued this challenge to the engineers of Britain. Produce an engine which must be capable of drawing after it, day by day on a well-constructed railway on a level plain, a train of carriages of the gross weight of 20 tons at the rate of 10 miles per hour. The prize was £500, and the engineers hoped a full order book.
The Stephensons took up the challenge at once. George was busy with his civil engineering commitments, so it was his son Robert who was largely responsible for building the locomotive. It was simply known in the books of Robert Stephenson and Company as the premium engine. We know it under its later name, Rocket. Timothy Hackworth, the locomotive superintendent of the Stockton and Darlington Railway, was another contender. He set to work in the time that was left over from running a busy railway to design and build his engine, the Sans-Pareil. There was one rank outsider, Perseverance, designed by the Edinburgh engineer Timothy Burstall. These three had a mere 5 months to design and build their engines. The fourth competitor had even less time. A young Swedish inventor, John Ericsson, had a letter from a friend in Liverpool at the end of July, which, in the middle of some general chat, happened to mention a steam race. Ericsson went off to his partner, John Braithwaite, who had an engineering works in London, and they agreed at once that they should enter. They based their design on their own successful London fire engine and called it, very appropriately, Novelty. There were 7 weeks left. Now all the main competitors were well and truly into the race. The anniversary of the great contest is to be celebrated, and former ICI executive Michael Sato, who'd built the locomotion replica, was asked by the Science Museum to build a replica of Rocket. He eventually agreed, but didn't want to stop there.
The Rocket was really no good without the competitors for the Rainhill Trials, and therefore if we were going to have a Rocket, we must have a Sans-Pareil, and we must have a Novelty. Now, there was only one logical place where we could build Sans-Pareil, and that was in Shildon, where Hackworth built the original. British Rail agreed to come in on the project as a training exercise, and Cecil Atwood, great supporter of Shildon, agreed to put up the money for that. I went off to complete the trio and saw my friend Bill McAlpine, and he agreed to add Novelty to the stable at Flying Scotsman Enterprises and put up the money for that one.
The first Rocket was built at Newcastle, 5 miles away at Springwell as part of one of Stephenson's old colliery railways. And it was here in April 1978 that Mike Sato established a company to construct 2 of the 3 replicas.
Good morning, and may I welcome you to Locomotion Enterprises. We are the first training...
The aims of Locomotion Enterprises are not just the construction of the replica locomotives. It includes the training of youngsters and the giving of employment to school leavers who otherwise would be out on the streets and probably up to much less constructive pursuits. So we went along in 1977 and put a proposal to the Manpower Services Commission in London that we might set up a training workshop, bring in project work of this type, which has an interest in itself and with which youngsters could be associated and which they would remember 50 years hence and could show to their grandchildren as something in which they'd participated. We're teaching them a number of skills: pattern making, woodworking, sheet metal work, welding, forging, working machine tools, and of course fitting. And these are all being taught by professional time-served supervisors. This is all part, of course, of the Manpower Services scheme for training workshops. And we like to think that we have perhaps a more comprehensive range of skills than most of the other workshops that have been set up.
A bit more on the top now.
Mike Sato managed to beg some vital equipment, such as this milling machine, from sympathetic industrialists. But even then, not all the parts could be made on site.
Have you got a short bolt?
So again he turned to local industrialists, who happily incorporated the work into their conventional training programs.
Ready?
30 miles away, at the other end of County Durham, is Shildon. It's a railway town. Indeed, it's the first railway town, built up around these works, established here by the Stockton and Darlington Railway more than 150 years ago. One of its first and certainly most famous citizens was Timothy Hackworth. This is where he lived, and today his old home houses the Hackworth Museum. A prize exhibit is this magnificent model of Royal George, one of the finest engines to run on the Stockton and Darlington. It was built by Hackworth, who was appointed resident engineer after a short period of working for Stephenson at Newcastle.
Timothy Hackworth was rightly regarded as one of the best engineers of the day, so it was only natural that he should want to enter for the Rainhill Trials, and he began building his locomotive, Samparai, right here at Shildon. And it was here, too, that he established his own locomotive business at the Soho Works.
This is the model of the works as they were at the end of his career. Not much survives: the house and the cottages and one solitary shed. The Soho engine shed is also part of the Hackworth Museum, and it's here that the replica Samparai will be assembled.
And to wish it every success and to officially declare the Soho engine shed reopened.
Chains of office were much in evidence at the official opening, and quite right too. The district council had shown an enlightened attitude. It's not that easy to persuade local authorities to put cash into restoring crumbling railway sheds.
I have great pleasure in asking you, Mr. Chairman, to present to the Hackworth Museum this commemorative plaque.
Thank you very much.
Now the rivals could get down to work, just as their predecessors had done. But then the locomotive was still new. Those early engineers were the avant-garde of the new technology. The steam engine's basically a simple machine. Water's heated in a boiler to form steam under pressure. The steam passes to a cylinder where it pushes against a piston. The piston drives the wheels. There is, however, a difficulty. You need a great deal of steam to make the engine work, and you can't just have a vast boiler, since all the power would be used up just moving the boiler around. So the key to success for locomotive builders lay in finding a way of producing steam efficiently. The three competitors came up with three quite different answers. Samparai had a very simple system. A flue carrying the hot gas from the fire passed through the boiler and then doubled back again so that more of the hot metal could be brought into contact with the water. The replica of this 150-year-old boiler was assembled at British Rail Engineering Works at Crewe, in a space usually reserved for the latest high-speed train. The double tubes form the flue, which is lowered into place in the outer case, the boiler. The original boiler was made of riveted wrought iron, but here, as with all the replicas, welded steel has been used to meet modern safety requirements. There were no such regulations covering the originals, and as early as 1829, there had already been a number of boiler explosions in which railwaymen had died. Novelty was quite different from Samparai. The firebox was rather like an old-fashioned stove, and the gases passed along a tube coiled up like the entrails of some animal. It certainly brought a larger surface area into contact with the water than Samparai, but the closed stove brought other problems. Rocket was different again, and the solution found here was to form the basis for all later steam engine designs. The firebox was separate from the boiler and surrounded by a water jacket. The hot gases escaped through a series of narrow tubes passing through the boiler. Here was a simple way of ensuring that the maximum amount of heat passed from the fire to the water to raise steam.
Stephenson, in fact, fitted 25 3-inch tubes. On his subsequent batch of engines for the Liverpool and Manchester Railway, he went far beyond that and fitted about 90 tubes to his boiler, smaller tubes. Now, we have, in fact, jumped the rocket stage as far as the boiler tubes are concerned. And we've done that after due consideration because we recognise that Stephenson had seen the merit of the multitubular boiler. He took it to 90 tubes almost within a year, and we want to see just how good that boiler was, because that was really the prototype of all subsequent locomotive boilers. And the other thing was that in updating our constructional techniques, we have used standard boiler tubes instead of having to have special ones made, which would be a liability to the people who've got to maintain the boiler in the future. George Stephenson was an instinctive, an intuitive engineer. I mean, after all, he was illiterate for most of his life, and he had a feel for the materials in which he was working and could visualize, I'm quite certain he could visualize the end product. before he built it. And I personally feel very close to him at times when we're grappling with design problems. Quite often, you see, we do not have complete details of the items we're trying to design. Parts have been lost, so we have to work out what they were like. Now, I find that the best way, and probably the only way to do this, is to try to project myself back to 1824 or 1829, whenever it may be, and try to create around myself the environment in which he found himself working.
At the British Steel Corporation Training Centre at Middlesbrough, young trainee draftsmen had something of a change from drawing bits of blast furnaces. They were preparing plans for novelty. This proved the most difficult of the replicas. No original plans survive, and there's not a great deal of the old engine left either. A difficult job and a challenging one.
There's a lot more interest in a job like this because, you know, when you're working with the normal training programme, it's just straightforward laid down. But with a job like this, you have to think things out from their point of view and how you could modify it to suit today's, you know, standards and today's materials, because a lot of the material they used in those days, some of it isn't available in nowadays, you know, or it's too expensive to use nowadays.
Well, we were given 3 drawings of a scale model which is actually in the Science Museum in London, and those were the only things we had to work off originally. And this was the proposed arrangement of the novelty. Looking back on it now, it's incomplete in certain details because we weren't sure of details of the cylinders, etc., and valves because they weren't shown on the original drawings of the scale model. It's quite remarkable, really, that something like this would work, in fact. There hasn't been much change, really, since then, in actual operation. Obviously, materials have changed, materials have been strengthened, but actual operation hasn't changed a great deal.
The drawings of the young draftsman now had to be converted into iron, but the first stage doesn't use metal at all. This is one of Novelty's cylinders being built as a wooden pattern. This pattern is pressed into sand in a special box, and when the pattern's removed, the exact shape of the cylinder is left in the sand. Molten metal is then poured into the cavity. So the metal cylinders are cast using precisely the same techniques as were used back in the 1820s. And now the replica builders found history repeating itself. We know that Robert Stephenson had great difficulty in getting good castings for rocket, and his successors found it no easier. The problem was one of basic design, and there were many false starts before perfect cylinders were produced. In 1829, this problem was not unique to Stephenson's own engine. He was also entrusted with casting cylinders for Hackworth's Samparai, and the problems he met there were to lead to arguments that have continued to this day. Casting in sand is an old technique, but when it came to making the wheels for rocket, the builders had to go back to an even older tradition. Machine tools didn't exist at that stage which could accurately turn big wheels, and at 4 foot 8 inches diameter, rocket's wheels were very large, and in any case, weight was an important factor. So the wheels were wooden with an iron tyre, and for the replica, the wheels were made by wheelwright Ernest Bailey, a man well versed in this old craft.
The business was started in 1880, and 98 years it's been going now in the family. It was started by my uncle, who was the oldest of the family, and my father, who was the youngest, served his time with his brother, and I in turn served my apprenticeship with my father, and now Norman, who's my son, he's taken over the business from me 3 years ago.
The wheels are composites, with elm for the nave or hub, oak for the spokes, and ash for the rim. But Mr. Bailey had problems that wouldn't have plagued his ancestors.
Well, the main problem is getting seasoned timber, which is not generally available today. The reason being that no one can afford to have as much money sunk in stock for several years without getting a return for it. So we've had to just search around and find timber that has been used for other jobs that is dry and seasoned.
The tape from the on the circumference straight away around.
But whatever the difficulties, the wheels were finished and sent off to Springwell. There they came under the critical eyes of the works manager, Andy Raffle, and the pattern shop supervisor, who carefully checked the dimensions.
Yeah, we're in with an inch and a half of that
on the circumference.
Yeah,
Should be.
yeah.
Contract 3/4 of an inch.
Oh, and then there's we've got an 1/8 of an inch there.
In fact, Mr. Bailey had done his job so well that when it came to the next stage and the metal tyre was heated and dropped over the rim, it cooled and shrank to a perfect fit.
Fetch a contraction in that way.
So we've got about 5/8 contraction.
5/8 to 3/4, yeah.
Yeah, that's snapped two of them slots there, so we'll fit that one now, okay?
Okay.
Right.
From the first, the Liverpool and Manchester Company were agreed that their line should carry passengers as well as freight. Though in the original Act of Parliament, the passengers were unceremoniously lumped together with the rest of the livestock as persons, cattle and other animals. Early passenger coaches often seemed little better than cattle trucks. This is a replica of a third-class coach. The second class had the luxury of a roof. No, the sides were only built up to waist height, but only the first class enjoyed the ultimate luxury of a completely closed carriage and padded seats. At last, in May 1979, months behind schedule, Rocket's boiler is delivered to Springwell. It's only one component among many, but it stands at the heart of the engine. It's the core around which the rest of a locomotive is to be built. Once the crew have manhandled the boiler into position, they can get down to the serious work of assembling Rocket. At the same time, the firebox was delivered. Robert Stephenson had also had his original firebox made by outside contractors, and he recorded that when it arrived it wasn't quite square. 150 years later, Andy Raffle finds the modern replicas no better.
So the technique that we use is to put a cross-section, which we basically call a set-out, on the plate and merely drop the firebox wrapper plate around it, and then we'll then discover where she actually wants pulling in. And if we take a look at this side here, you'll see that we want that fella moving in. But that's got to move from this corner.
With firebox and boiler united, Rocket's steam-raising unit is complete, but it still has to pass official inspection. It's filled with water under pressure to test for leaks. When Stephenson tested his boiler up to 70 pounds, he found that the end of the boiler bulged out 3/16 of an inch, which, in his own words, put a severe strain on the clunking of the tube ends. If Sato's boiler doesn't do better than that, he'll have to start all over again.
That's quite good, isn't it?
Everything now depends on what the inspectors have to say.
How long do you want the pressure on? How long have you been on now?
10:15. Leave it on for a quarter of an hour, right?
1 hour. 15 minutes.
No bother at all, really. The pressure's gone off.
You satisfied?
Oh, quite satisfied, yeah.
I think anybody's pretty relieved when a new design of boiler passes its official test. because this has been a particularly troublesome boiler to redesign. You see, Rocket's original boiler would never have been allowed to be built today, certainly not as a working boiler. And we had to do a complete redesign of this to convert it into a welded construction. We had to alter the whole system of stiffening it and staying it and strengthening it. And there's no precedent for this particular design. And happily, it went through its test very well indeed.
Now they had the green light. The team moved Rocket to the erecting shop for its final assembly. It was to be the busiest time of the whole construction period, with work going on round the clock to get the engine ready on time. If anything, life must have been even more hectic at the Stephenson works 150 years ago. George was away in Lancashire, overseeing work on the line, so the whole job of planning and supervising the work fell to his son Robert. To add to his troubles, the works were busy with other orders. There were 5 locomotives and a colliery engine on the books when work started. It seems amazing to us that a revolutionary new engine could be built from scratch in a busy works in just 5 months. Of course, not all the components of Rocket were of new design. In many cases, Robert and his very able assistants used well-tested items, parts which had been developed from earlier Stephenson engines. He had quite enough to cope with in the way of experimental features in the boiler without making difficulties elsewhere.
That September, Rocket was given a successful trial and was ready for Rainhill. And at the same time, there were 2 other engines being completed in the Stephenson works. One was a locomotive bound for America, the other a stationary engine for the Liverpool and Manchester Railway. And both were to be shipped round the coast of Scotland to Liverpool. And it could well have been that they'd thought of putting Rocket in the same vessel. And it's a good job that they didn't. It's fortunate because the vessel sank. And if Rocket had been on board, the Rainhill story would have had a very different ending.
And there would have been a different picture on this canvas. The 5th of August, 1979, the day of Rocket's official handover has arrived, and there's still some last-minute work to be done. The boiler's filled with water, and the kindling brought out for the fire. It's an oddly domestic interlude, rather like laying the fire in Granny's kitchen grate. In May 1980, the engine will make another public appearance at the grand celebrations to be held at Rainhill. There it will be joined by its 2 competitors and a host of other steam locomotives. But for today, Rocket has the stage to itself. Actually, the original got its name at rather a late stage. When it left Newcastle, it was still known as the Premium Engine, but it arrived at Liverpool dignified with its now famous name, Rocket. Today, the honour of lighting up the engine goes to Kel Evans, Springwell's youngest trainee.
From one side to the other, Kel.
The man who did it all, Mike Sartor, chairman of the Tannery.
How do you do? How do you do?
Now the time has come for Mike Sarto to present his engine to the director of the Science Museum, Dame Margaret Weston.
I think it was about 4 years ago that Dame Margaret twisted my arm and said that she wanted Rocket. She was more polite than that. She would like to have a Rocket, 1980. And I resisted that and said, no, it was impossible. 1 locomotive in a lifetime was enough for anybody. But in her characteristic way, she persisted and succeeded. And she has come here today to see the fruits of our labours.
First of all, my lords, ladies and gentlemen, I think you'll understand that I must thank Michael Sato before I say anything else. Michael, it's been absolutely splendid. Now I would like to say a few words, because I want to thank all the people here who've been responsible for building Rocket. I'll go and see what I can do with that bottle. Anyway, let's have a go.
No, don't knock it off.
You reckon not? You reckon not? Oh, you see? No, wait a minute.
The beast lives, but is still in chains. With no brakes yet fitted, Rocket can't be allowed out on the lines, but the wheels are jacked up and everything works.
I feel pretty relieved. More so than I was at 9 o'clock last night. We were finally finishing off the painting work. And of course, even this morning when we started it, there were certain items on it which were untried, which were not included in the test which we did on Wednesday. So, you know, one had to have a certain amount of faith, which has been justified, I'm happy to say.
Pleased to see this finished, I'll tell you. It's a load off my mind. Fantastic.
Really, it's an achievement. We've had to work hard for it, but it's something to me, it's out of this world. It really is.
It's a real sense of achievement and a great deal of satisfaction when one sees the thing in motion this morning.
I suppose everybody likes to play with trains. We've had a chance to make one.
Over at Soho, Sam Parai still has a long way to go. Playing Hackworth to Sato Stephenson is British Rail Engineering Training Officer Colin Ampleby.
I think it's true to say that some of the problems that we've experienced in building a replica were those that were experienced by Hackworth himself. I think it's also an interesting point that it's just over a century since the last steam locomotive was in fact built at the Shildon Works. One thing we have experienced with this particular project is the fact that we've become so accustomed over the years to components, leaving a machine and going straight into an assembly situation. A craftsman picks the part up and can introduce it into its appropriate place on a vehicle. Now, in this case, the apprentices and the craftsmen concerned and the training staff have realised that each part had to be individually fitted to the locomotive. There was filing and scraping to do to the various components, each one being tailored to its appropriate place on the loco. Yeah. This is a challenge to them. It's part of the Shildon history. Shildon Works is very much a family business. They tend to look on Shildon Works as their own. It gives them a lot of pleasure in being able to achieve these objectives.
Back in 1829, there were dark tales of industrial espionage being spread around. Well, talking to Mike Sato, he mentioned something about the tender and suggested that it wasn't altogether absent today. Is there any truth in this story?
There is certainly no truth in the rumour. I think you're referring to a water barrel, which Mike alleges I stole from him. I think the truth of the story is that I probably was a little bit nearer to one of the senior members of one of the local breweries and managed to take delivery of a suitable pipe of port barrel, which we would use for the tender water barrel, before Mike got there and picked the barrel up.
Early one Sunday morning in November, Sam Parai is steamed up for what everyone hopes will be a successful first run. The past week has seen a lot of frantic work to get the valve settings right, and in the end, an ex-valve setter had to be brought back to his old job. But what about the original and its builder? Someone who has very definite views about both is Timothy Hackworth's great-great-granddaughter, Jane Hackworth-Young.
I think he was a very modest man. I think he was a very brilliant engineer, but he didn't blow his own trumpet. And perhaps that's why he's not known so much by the public as some of his contemporaries.
Was Samparai, in fact, a good locomotive?
Well, I and a lot of the family think it's far better than the Rocket. But I think that Hackworth was unlucky. First of all, he had to make the locomotive in his own time. He was working for the S&D railway, and everything that he did, really, for the building of Samparai had to be done almost at night by candlelight, and he didn't have his own works. But it was a very powerful locomotive. After the Rainhill Trials, it went to the Bolton and Lee Railway, where it ran very successfully until 1844.
Well, now the moment has come for the engine to be put to the test. For Colin Umpleby, it was the moment of truth as he opened the regulator to bring Samparai to life.
It really is.
I think just to look at it, you know, when you compare all the others, there's something about this locomotive that really, there's nothing quite like it. You know, there's something you were proud of, aren't we, really?
Well, you know, it's part of the Hackworth family, is this?
It is indeed.
Absolutely.
The Shildon team who did the final assembly were all on hand to see that their engine worked. But so far, Samparai has only made a first cautious move out of the shed. Now, with a Hackworth on the footplate, it was to be put through its paces.
What a character, mate.
In the original engine, Timothy Hackworth used a device known as steam blast, sending the exhaust steam from the cylinders up the chimney to increase the draft of the fire. And you can hear it quite distinctly in that steady chuff of the replica. The first day's trial was successfully completed. It was only a short run, but then Hackworth himself only had time to give his engine one quick run at midnight before it was sent to Rainhill.
Jane, you've had your ride on Samparai. What's it like? It's not marvellous.
It really was wonderful.
Is it as good as you thought it would?
Yes, I think it's better. It's a jolly powerful little loco, isn't it?
Is it really a good engine?
I think it's going to win this time. Out of doubt.
Colin, how would this work in a Rainhill trial if you could run it today? Would it have a chance of winning?
I'm sure it would, no doubt in my mind at all. If you're asking me whether it'll win when we get to Rainhill next year, well, if it wins, history will have to be rewritten. But if it has to be rewritten, well, all we're doing is putting right what was wrong last time.
Last time, in September 1829, everything that could be done to the originals had been done.
So at last the competitors were ready, and they came here to Rainhill. Now the whole future of steam locomotion was in the balance, and Britain knew it. I want you to imagine that scene in October 1829. All the roads around here were crowded with people rushing in on foot, on horseback, in carriages. Over here they built a huge grandstand which was packed from early morning, and people jostled and pushed on both sides of the track to get a view of these mechanical monsters. Because, you see, most of them had never seen a steam locomotives in their lives before. What were they going to do? Would they explode? How fast would they go? 10 miles an hour? 20 miles an hour? An almost inconceivable 30 miles an hour? The tension must have been absolutely tremendous as the crowds waited for the first locomotive to begin its first run.
Rocket was first out on the tracks, and the crowd scrambled for a view. Now, in August 1979, in London's Hyde Park, the replica of this fine old engine is making its first public appearance. But while we admire a pioneer, a reminder of an age gone by, in 1829, Rocket was the latest thing, a mechanical marvel travelling at previously undreamed-of speeds. Where we see an old engine lumbering by, they saw a new engine that seemed to fly.
And those who are lucky enough to travel behind one of the amazing new machines described how the sheer speed reduced the whole world outside to a mere blur. If it did nothing else, that first day showed that a new age of speed had arrived. But if the whole issue could have been decided there and then by popular vote, novelty would have romped away with the prize.
The replica, with Mike Sato on the footplate, made its first cautious appearance under steam in May 1980. Even in its unfinished state, you can see why the crowds were so enthusiastic. Everything about it said lightness and speed. It was as sporty as a gentleman's carriage. It looked a winner. Everyone was expecting to see something really special as it came up to the mark for its first trial run. They were to be disappointed, and events at Springwell got off to an equally unpromising start.
But it wasn't the sort of accident that happened to the replica here on its first run that caused the real trouble. It was capable of speeds of up to 60 miles per hour, as Ericsson proved, but it did lack power, and that curious heating mechanism always gave trouble.
Yeah. Come on.
It's all right, it's honestly. Just
What's your side like, Ozzy?
All right, yes, sir.
Come on.
Wait, hold it there.
Once it got going, it was, as the Liverpool Mercury reporter declared, one of the most sublime spectacles of mechanical ingenuity and human daring the world ever beheld. It actually made one giddy to look at it. Had it done as so many predicted and won the prize, then the whole railway system might have developed in a quite different way, with a multitude of light, fast vehicles, more like the road system than the railways we know today.
But speed was not the only quality to be put on trial. Strength and reliability were also to be put to the test. The next few days were to be less glamorous, but a good deal more important. The first day was something of a disappointment. Novelty made one run and then retired with mechanical problems. Sans Pareil didn't run at all, and Timothy Birstall's Perseverance was still in pieces. Stephenson, never a man to miss an opportunity, made demonstration runs with Rocket. And then the rains came down and washed out all the proceedings for the day. At that late stage, the competitors were told the conditions. They were to make 20 runs up and down the mile-and-a-half-long track, the equivalent of a return journey from Liverpool to Manchester. On 8th of October, 1829, Rocket made its attempt.
It performed admirably, safe and secure throughout. And then, on the last run, Stephenson let the engine go. The regulator was opened wide, and Rocket thundered down the track, covering the ground with a full load at 29 miles per hour. It was a triumph for the Stephensons. Now they could sit back and let the rest try and match them.
Novelty was the popular favourite, but Stephenson summed it up in 2 words: no guts. And so it was to prove. 7 weeks was too short a time to prepare a locomotive for Rainhill. Ericsson worked furiously at his engine, but there were too many faults, too many things went wrong, and to the huge disappointment of the crowds, Novelty was withdrawn. Perseverance never really got going at all, and that left Sans Pareil, the one competitor that the Stephensons feared. They knew Hackworth, and they knew his worth.
And Sans Pareil proved that it was indeed a powerful engine, though like Novelty, it was to be plagued by faults. But it made 8 successful runs up and down the Rainhill level, and it matched Rocket for speed all the way. Then the problems appeared. A pump broke, and, very ominously, a fault was found in one of the cylinders. Now, Hackworth had no factory of his own, so the casting of the cylinders had to be entrusted to Robert Stephenson. Here was fuel to stoke up controversy for years to come.
In those days, it was a very, very difficult science to bore these cylinders accurately, and but a lot of people, I think, felt that it could have been sabotage, and it might have been done on purpose.
Do you think it was sabotage?
I don't really think so. I think it was unlucky. But there was a tremendous amount of talk at the time, and there has been a tremendous amount of talk ever since.
Yet the cylinder controversy is not really all that important. Good as it was, Hackworth's engine marked the end of the old tradition of colliery locomotives. Sans Pareil offered nothing to build on for the future. So it was Rocket that carried the day. Rocket, the first truly modern steam locomotive from which every other railway engine was developed. Rocket, the great original.